shit. Hold on. Off the charts. Let's see if I can get these to stay. There we go. 20 volts, it's off the, it's over 600. I come back down to 12. You see, there it is. Not 600, so I know I'm probably then that's at 13.5 volts. So at 24 we get over 1,000, maybe 1,200. This is really cool how it has. There's the DC commutator driven here, which allows it to be directly voltage controlled RPM, and then there's two more commutators over here. This one in the back here, the slightly larger one, produces the commutator rectified DC, and on the front one here, I can't tell. I'm only reading like 12 volts DC on it, so I don't know if it's directly connected or what, or it's just getting EMF from the stator, the static DC stator that's also here. But it can go beyond 4K RPM, which allows us to switch at that rate, perhaps more with all them commutators. Turn it off here. Still a lot of voltage as it barely spins down, but there's quite a bit of I don't know, maybe 30 of them. And then on this one, they're the same size, and the diameter's almost twice. So maybe there's 60 here, I don't know. But these are the rectified DC outputs here from this one, and then these two are it reads 12 volts DC. But I'm wondering if this is just an auxiliary commutator that you can use for switching at RPM times commutator points. We shall see. Oh yeah, I got this guy too, but I don't remember it being that in the picture. So both sides were shorted. They had a wire going on it. On the left's the low voltage, on the right's the high voltage. So this should be giving me 220 volts DC, but at 7,500 RPM. And these are both continuous duty. I was really happy about that. But this one doesn't want to turn yet. It seemed like it was loaded down when I hooked up the power supply, but I may have to open it and attempt to oil it and make sure it turns first. But this thing, I can't believe this thing. This thing will be very handy. Very, very handy. Whether the HVDC or just the voltage controlled RPM commutation.